Alright, in this video you are going to be given a quadratic function and you will be able to use the vertex and axis of symmetry to create the graph. So a couple things we need to talk about first is what a standard form of an equation looks like. So a standard form of a quadratic equation is y equals ax squared plus bx plus c. So a will be the coefficient of your x squared, b is the coefficient of your x, and c is the constant. The axis of symmetry. Axis of symmetry is the line where, let's just put this right here, we're going to say the line where the graph folds in half. So a line where the graph folds in half, and it's represented by x equals the opposite of b divided by 2 times a. So what does that look like? These graphs are all going to be parabolas, which will be either facing up or facing down. I should say opening up or opening down. The axis of symmetry is going to be the line that folds. So again, the axis of symmetry will be these orange lines I'm about to make. Those will be your axis of symmetry. Alright, so the next question is, what is the vertex? Well, the vertex is either the minimum of your graph or the maximum of your graph, depending on what your graph looks like. Okay, it's either going to be the minimum or the maximum. So it's the minimum if it's the very lowest point of your graph. The vertex will be right here. And you'll have a maximum of your graph if your graph is opening downward. The vertex will be the maximum of your graph. Now, one thing to note here is that your vertex always lies on the axis of symmetry. And just for fun, to keep things easier for future reference, axis of symmetry, I'm going to call that AOS, axis of symmetry. Alright, the y-intercept. The y-intercept will be where, just like on my linear equations, the y-intercept is where my graph will cross the y-axis. Except in the linear equations, that's with the y equals mx plus b slope-intercept form. The y-intercept is where we began graphing our lines. That was the b. In this case, it's a little bit different with parabolas in standard form. So y-intercept is where the graph crosses or intersects the y-axis. And that point is represented by 0, c. Again, you look up at the standard form, the c is my constant at the end. It's always going to be 0, c, because if we go 0 sideways and either up or down to get on my y-axis. So with that being said, let's start graphing a couple of these. So the first thing I want to do when I'm graphing an equation in standard form is I want to point out what my a, b, and c are. So I'm going to start here by saying a, b, and c. Now remember, the standard form of my equation is y equals ax squared plus bx plus c. Again, a is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the constant. So looking at my equation below, my a, there's no number in front of x squared, so that's a sneaky 1. My b is the coefficient in front of x, which would be 2. And my c is the constant, which in this case is 4. Alright, let's do the next part. The next part we're going to do is graph the axis of symmetry. And that's represented by x equals the opposite of b over 2 divided by a. Now what does that look like? the axis of symmetry is the opposite of b. So b is 2. The opposite of b is negative 2, divided by 2 times whatever my a is, which is 1. Here I have negative 2 divided by 2 times 1, which is 2. That turns out to be negative 1. So it's x equals negative 1. So what does that look like on my graph? On my graph, I'm going to graph a vertical line because x equals is a vertical line at negative 1. I'll graph my vertical line at negative 1. I don't necessarily want to draw it a solid line because it's not part of my graph. It's simply where the graph folds. Now to find the axis of symmetry, I am going to, to find the vertex, I'm going to substitute my x value in my equation. So let's do that next. So to find the vertex, I'm going to substitute, it's going to be y equals x squared, so negative 1 squared, it's important to use parentheses with these, plus 2 times negative 1 plus 4. So if I type this all into a calculator right here, that's 1 squared is 1, plus 2 times negative 1 is negative 2, so I have 1 minus 2, that's negative 1, plus 4 is 5. So 1 minus 2 is negative 1, 1 squared, negative 1 squared is 1, minus 2 is negative 1, plus 4 is 3, so y equals 3. So my vertex is actually the point negative 1, comma 3. So let's graph that point real quick. Negative 1, 3 will be my... Alright. The next thing to do is to find my y-intercept. And my y-intercept is going to be 0, comma c. Now remember c is the constant by itself here, which is 4. So my y-intercept is 0, comma 4. Alright. So I'm going to graph that point 0, comma 4. Now, what you need to know about these parabolas is they're U-shaped graphs. And I know that this axis of symmetry splits my graph exactly in half. It's a mirror image on the right side as it is on the left side. So if I know anything that's, say, 1 spot away from the axis of symmetry here, my other point would be exactly the opposite on the other side. So if this point, if my y-intercept is 1 spot to the right of the graph, my mirror image point would be 1 spot to the left of the graph. So I can go ahead and I have 3 points. And remember, this is a curve. It's not a V. Alright, next graph. So here I have y equals the opposite of x squared minus 2x minus 1. Again, the first thing to do is label your a, your b, and your c. Remember, my standard form of an equation is y equals ax squared plus bx plus c. Keeping in mind my a is my coefficient of the x squared, b is the coefficient of x, and c is the constant. So again, the coefficient in front of the opposite of x squared is going to be a negative sneaky 1. The coefficient in front of x is negative 2. You have to keep the negative with it. And the c by itself, the constant, is negative 1. This graph is very negative. Alright. So the next thing we have to find is the axis of symmetry, AOS. X equals the opposite of b over 2 times a. Well, what is our b? Our b is negative 2. So the opposite of negative 2 is positive 2, divided by 2 times my a, which is negative 1. Interesting here. 2 divided by negative 2, this is also going to be negative 1. So my axis of symmetry of this graph is x equals negative 1. So again, we're going to graph our vertical line, our axis of symmetry, at x equals negative 1. It won't always be negative 1, by the way. If you were to get x equals 3, you'd graph it at the 3. If you were to get x equals negative 4, you'd graph it at the 4. We just happen to have two graphs that have the same axis of symmetry, and that's okay. So the next thing we want to do is find the vertex, and we find the vertex by substituting my x value in, because remember, my vertex lies on the axis of symmetry, so we know that no matter where I'm at on this line, I'm always going to be 1 to the left, which is x is negative 1. So if I use this x is negative 1 to find my vertex, that'll work. So You have to be real careful when you're plugging these in. So the vertex is substituting -1 back into my equation. So I have y equals the opposite of -1 squared minus 2 times -1 minus 1. Alright, so if I do this in my head here, I have the opposite of -1 squared. That's the opposite of 1. -2 times -1 is positive 2. And then I have minus 1. So I have -1 plus 2 is 1, minus 1 is 0, so y equals 0. So my vertex is actually a point. It's a point on this graph. It's going to be my maximum or my minimum. -1 comma 0. So we go -1 and we go up 0, and my vertex will lie right here. Now, my y-intercept is 0 comma c, and my c happens to be -1, so it's 0, -1. So right here, 0, -1. And again, everything over here will be equidistant to everything over here. So this is my mirror image, my mirror right here. If my y-intercept is 1 point to the right of the axis of symmetry, the mirror image point will be one spot to the left. And again, it's a curve, not a V. So this right here, my vertex here will be a maximum. Alright, my vertex here is a maximum, and my vertex over here is going to be a minimum because it's the very low point of my graph. And there is actually an easy way to tell if you're going to have a maximum or minimum. So let's add this down here. If your A value is positive, it will open up. So what does that mean? That looks like this. And you will have a minimum. And the opposite is true over here. Oh, my crummy looking star. If your A value is negative, your graph will open up. Will open down. Like this. And you will have a maximum. Don't mind my messy handwriting. Holy smokes. If A is negative, it will open down, and you will have a maximum. So the key things to remember when you're graphing a parabola in standard form. Now it's your turn to practice.